Thank you very much. So today we're going to talk about something that I could easily put you to sleep. It's important information, but I'm going to try to keep it as exciting as possible, but I am an engineer, so keep that in mind. So today we're going to be talking about regulatory considerations for extraction operations. My expertise, our company does mechanical, electrical, plumbing engineering. I'm a professional engineer licensed in mechanical engineering. So my background has always been in HVAC, heating, ventilation, air conditioning. Within that realm does come any sort of ventilation comes into that, and extraction facilities have a great deal of ventilation requirements. So that was kind of how we got into this. We've now employed an electrical engineer. There's a lot that goes into the electrical component and even the plumbing components when you're setting up these facilities. So keep in mind that what we're going to talk about is mainly the facility design, not the parts and pieces of the extraction equipment. However, I know a little bit about that, so if you have questions, I'd be happy to talk to you about that afterwards. So, or definitely put you in touch with people that know more than I do. So this is just about us. My company is called Colbright Engineering. We're based in Bend, Oregon. I started Colbright in 2013, and right about 2014, we started getting calls for cannabis cultivation, mainly at that point, to get more into that arena. So after we did quite a few projects, we decided to rebrand our cannabis arm as Root Engineers, and we're trying to build our brand nationally. We're licensed in quite a few states, and we can usually get licensed pretty quickly in others. Our thing is that we really provide a service. That's all we do. We don't sell a product. There are lots of people out there that sell products. We are system agnostic. We're really just looking out for what the customer needs in terms of just what they're truly trying to get, whether it's just a code compliant facility or something that's super efficient. That's what our job is, to meet your needs. So today I'm going to touch on popular extraction methods. However, I'm going to skew it a little bit towards hemp, and especially large production hemp, because that seems to be what's going on right now. That's what all of our projects right now that are in the cannabis space are in larger hemp extraction facilities. There are many regulatory considerations that go into this, and I'm going to give you an overview. I'd be happy to share this presentation with you afterwards because it's a lot of information, but I've written it so that it can be shared so that you kind of have a cheat sheet to look at, share with your designer, whatever you want to do there. And then I'm going to get into some common mistakes while keeping innocent parties innocent, things that we've seen that, it's just something to look out for and make sure that you've got engineers and designers that really know what they're doing. So these are the most common extraction methods, and when I talk about these common extraction methods, this is mainly just cannabis in general, not necessarily for hemp. When we first got started in this, it was mainly BHO was the main thing we were seeing, which butane hash oil is what that stands for. In that case, they were using butane as the solvent, and I'll get into a little bit about what that is there. Alcohol solvent, ethanol, mainly, and this is what we're seeing a lot in the large hemp extraction facilities, is this ethanol. CO2 is very popular, especially if you're looking for, and I'll call it a cleaner product, whether you want to call it organic or whatnot. This seems to be popular. It does tend to be a little more expensive, but it's definitely, from a safety perspective, it's my preferred method. It's got high pressures, but it doesn't have the flammability or explosivity concerns that these others do. And then, of course, the best, from my perspective, would be the rosin press. It's solvent-free. It just uses pressure. but I'm pretty sure it's not as efficient in terms of producing product as any of these others. So we very rarely see that. And usually it would be like a boutique business trying to, and mainly I'm not really sure when it would make economic sense, but I haven't seen it too many times. So there's this nomenclature called closed system and open system, and it's actually becoming a little more complicated than we used to think of it. So a closed system is, let me grab a note here, a moment here. So you've got your solvent tank. So let's just call this an ethanol process. So you've got your solvent in here, and then you're going to put your raw product, your hemp, in these material columns. And it's really, really simple. Basically, the solvent just goes into these material columns. It starts to dissolve the hemp. And this is a very simplistic view of it, and it spits out of it the hash oil, if you will. And that's what's in this recovery tank here. Now, in a closed system, there's a step that allows you to recover the ethanol or solvent off of this part and pump it back into this initial tank here without opening the vessel to the atmosphere. So it's inherently more safe than if you're doing something that's open. Now, an open system we used to think of as what I'll call open blasting. Basically, somebody takes their butane and they're working on their stove, and it's basically the same process, except it's all open to the atmosphere. Butane is terrible, the flash point super low, so you get an explosion, basically. So that used to be what we thought of as closed systems, open systems. Then comes large hemp production, okay? So what we found is that there's the extractor itself that is closed, like I just showed you. But they might be storing their ethanol right next to the extractor and literally pouring it into that first tank open. And that is an open system. It's not the safest, but it's doable. As long as it's designed properly, you can safely operate an open system, but it gets tricky. So you have to make sure that your designers know this code paths to make sure that you're safely operating. Okay, I'm going to go through this kind of quick, mainly because I don't want to put you guys to sleep. But basically, what I want to get across is how codes are put together, because there's this disagreement about whether or not there are codes in our world. And the answer is there are always codes for anything. You just have to know where to look. So in lots of states, we've got cannabis-specific codes. Many times they do apply to hemp. There are many that think that just because it's hemp, it shouldn't follow the cannabis codes. Well, when it comes to extraction in my world, it really doesn't matter what the product is. It's all the same, right? We're talking about solvents, we're talking about flammability, we're talking about explosivity, we're talking about high pressures. I don't care if it has THC or not. So I think that's an important thing to get across here. So there are model codes. Example of model codes would be the ICC, IAPMO, NFPA. Those are some model codes that they're basically nonprofits. They come together, they get all sorts of industry experts together to come up with these code sections. Here are some others. OSHA, ANSI, ASHRAE. So then those model codes basically are adopted by states. So, states that are generally a little simpler to operate in, they might just take the model code and adopt it exactly as it is. California, Washington, definitely are going to have a lot of revisions, and then they're going to adopt it. So as an example, in Washington, they've adopted the IBC with the revisions, the IFC, the NEC, the UPC, which is the plumbing code. This is the building code, this is the fire code, this is the electrical code, this is the plumbing code, this is the mechanical code, and then they have their own energy code. Even though there are model codes, and this energy code, they probably took pieces from ASHRAE and pieces from California and whatnot, but they essentially have their own code that they put together. And that makes up this Washington State Building Code. So most authorities having jurisdiction, which is the AHJ, if you've ever heard that term, they have some sort of a cannabis code. And many times, like when we got started in Oregon, we were using Washington's cannabis code at the City of Bend level because that's all they had to go off of. So they always have something to reference. Some of them don't allow hydrocarbon, which should be that butane or propane. Some of them require odor control, and some have noise mitigation requirements. It can be, sometimes that's, as an example, there's a county code where we're located that you can't have more than 30 decibels at the property line, which is pretty ridiculous. So you just have to make sure that your designers are aware of what the codes are. If they're professionals, they should be. It's not a big deal. But there is a lack of consistency in codes right now, and it's just the way it is, and something to deal with. Now, NFPA did recently, maybe less than a year ago, come out with this NFPA 1, Chapter 38, which is specific to marijuana. It does specifically say that it's applicable to hemp, so that's taken care of there. It's pretty short. It's only, I think, 4 or 5 pages long, but it does talk about fire protection systems. Sorry, I keep pushing the wrong button. Fire protection systems, extraction rooms, whether or not there are gas detection systems required, egress means, fumigation requirements, and staffing requirements. Basically, the facility needs to be staffed all the time if it's running. So this is getting into specifics a little bit, but I like to educate people on this because many times you go to one of these trade shows, and I haven't even been to this expo floor yet, so I don't know what it looks like, but like, let's just call it MJ Biz, okay? It's huge, the huge cannabis conference in Vegas every year, and they've got these huge extraction machines, and they look really impressive, and they're very impressive. And they might say to you, yes, all of our components are UL listed, so you should use us. And you think, oh, that's really great. Well, many times, 9 times out of 10, and in hemp it's even more so because these processes are so much larger many times. They are not, the system itself is not UL listed. Each component may be UL listed, but the system itself, when it's assembled, is not. And so there's a path around that, but it's just something to be aware of, because when you buy this extraction machine, you probably want to know what you're getting, right? You're spending, let's call it $1 million for this extraction machine. Maybe, I hope for your case it's not that much, but many times the big ones are. So $1 million for this extraction machine, and then you find out that it's not UL listed. So now what you have to do is you have to go and find an engineer to peer review this thing and say that it basically is good. They're basically putting their life, their stamp on the line to say, yes, this is an okay piece of equipment. Well, many times, and this is what I want to get across, the manufacturers themselves, if they're worth anything, they've already done this peer review process themselves. So they have an engineer kind of on standby that's going to come in and do this report for you, fly out and do your certification. Once it's installed, you're good to go. You want to make sure you know what that's going to cost, right? Because if you're going to pay another $50,000 for this, you probably want to know that up front. So just kind of a lessons learned, something to keep in mind there. Another thing that is not discussed enough, and it's coming up more and more in the hemp world, is dust. If dust is present, there is potentially a deflagration hazard, which is basically, will it go boom? Generally, we're recommending to clients that they have their incoming product tested and that they also test the product at the end of the isolate at the end of the process. One recent client found that the incoming product, which we thought was going to be quite explosive, wasn't so much, but on the exit side, on the isolate side, it was quite explosive, and it became an issue because they wanted to be able to grind it, and their grinder had to be classified for that dust use. So this is something that I think the industry hasn't quite caught up with yet, that these grinders are going to have to be capable of being what we would call Class 2, Division 1 or Division 2, right? You think you've got this idea, okay, before I get anybody involved, I need to have my building secured. So you go out and you find a building that you think is going to work for your operation. You have some idea in your head of what you want this to look like, what your product's going to be, et cetera, et cetera. Normally that's completely fine. But what we ran into was a client had a large hemp extractor, and they sort of knew what they wanted to use in terms of what it was going to look like, but they hadn't purchased anything yet. But they had signed a lease on the facility. And so our team got involved on a scoping phase just to kind of see what we were dealing with. And the architect started to dig into it and said, your quantities are too high. They had these large quantities of ethanol. Well, you can deal with anything. With the right design, you can deal with anything. But the problem was that they had these large quantities that they literally could not be, I think they had to be 30 or 60 feet from the property line in order to actually do this process in this building. So they had to, get out of their lease somehow. Luckily they were able to, and they went to 45 minutes away in the middle of nowhere where they could be on in an industrial park where they had 60 feet to the next neighbor. So I think that that's a big thing that we're finding is people not understanding that the quantities of materials are oftentimes going to dictate where you're even going to do your process. So NFPA 497, it's essentially the code that tells us when something needs to be classified as Class 1, Div 1, Class 1, Div 2, or unclassified. So if you're familiar at all with Class 1, Div 2, essentially what it is it's how flammable and hazardous are these liquids. And so Class 1, Div 1 means that in normal operation, a hazard will exist. And Class 1, Div 2 means it's possible that a hazard will exist, but not normally. And unclassified is basically there's no risk. So that's kind of the way to think about this. So Class 1, Div 1, to give you an idea of magnitude, if you have Class 1, Div 1 versus Class 1, Div 2, you'll have to do explosion-proof lights no matter what. But the level of explosion-proof is what matters. And so an explosion-proof light that's Class 1, Div 2 is probably $200, but it's probably 5 times that for a Class 1, Div 1 light. So you want to make sure that your designer is not over-classifying, because that can happen. Many times people think of the room being classified, that it's a Class 1, Div 1 room. Well, that's really not it. It's actually, there are these bubbles around the pieces of equipment. And so there's let's say you've got, just to make it simple, you've got a barrel that you're going to pour ethanol into, okay? Which I don't recommend, by the way. But you've got a barrel you're going to pour ethanol into. Within 5 feet, I think it's 5, it could be 3. Within 3 or 5 feet of that, and it's listed in this, it's going to be a Class 1 Div 1 bubble. And then when you get outside of that for another probably 10 feet, maybe even 20 feet, then it's going to be Class 1 Div 2. And so your lighting level, how fancy your lights have to be, can be diminished. So it helps to have a designer that really knows that, because otherwise you're going to end up spending either, worst case, they're not going to classify it at all, and then you're going to have an issue where you might be blowing people up. But more than likely what's going to happen is they're going to say, well, the whole room's Class 1 Div 1. Everything in here has to be explosion proof. And that can get costly. And you are going to need, just by code, you'll need a professional mechanical and electrical engineer. Even in ag exempt, we're finding that they're requiring that. They're not requiring an architect, which I actually don't agree with, but they are requiring the MEP engineers still. OSHA. OSHA is not really my expertise. We do get into it a bit, just because what I like to do is put the OSHA requirements on my clients. So I think it's good for anybody that's planning on building an extraction facility. What I would say is hire what I would call an EH&S expert. There are consultants out there, and they can help you with, as an example, whether or not you need safety showers. We get into it enough to know where you do and don't need safety showers, just because it comes up a lot and nobody seems to know. Many times, especially if you're doing hemp extraction, you are going to need safety showers, which are different than eye washes. They require a lot more infrastructure, because OSHA and then the plumbing codes have adopted this. Again, OSHA is kind of the model code that the state codes adopt. They require tempered water in these emergency showers, and they require 20 gallons a minute for 15 minutes. And so you end up with a real large hot water demand. And so then you couple that with, we're out in the middle of nowhere. We don't really have natural gas available. So then people want to use electricity, and it can get quite expensive quite quickly. So it's something to know about. I think this last project we did, it was a 6,000 square foot extraction facility, and it was probably $30,000 for their emergency shower system. So it's not nothing. Food safety. Usually the health department drives what's required. We advise our clients to meet with the health department early. And people tend to get scared of the code officials, because you're afraid that if you give them a chance to tell you what to do, they're going to tell you to do everything. But it's actually kind of the opposite. If you sit down and meet with them and tell them what you're trying to do, you can have a good conversation, especially if you have good designers on your team. You can all sit together, talk about what they're going to require, talk about what might be reasonable, and usually move forward in a pretty easy path. Where we run into issues is where people don't contact the health department, and then their facility, if somebody finds out they're building it, the health department comes in, finds out they don't have hand sinks. Well, I can tell you need hand sinks almost everywhere. So you want to make sure that you're in touch with these people early, because it's always a little bit different. The authority gets to decide what they really want. They can interpret the codes the way they want to. And yeah, you can contest it, but you got to go to the state level, and that just, usually it's easier just to do what they want you to do. So talking to them early is usually a good idea. So these are just kind of some final thoughts I just want to drive home here. Licensed architect engineers are almost always required. Whether or not they're required, and of course I'm biased here, but it's really a good idea, because what we're talking about here is life safety. So what I like to tell people is whenever an engineer asks you a question, keep in mind that they're trying to figure out how scared they need to be of you and whether or not you're going to blow somebody up, because that's going to come back on them and their stamp. So regardless of whether or not you're required to by code, following good design practices is just good practice. And it's going to keep people safe. It's going to keep your insurance rates lower. You know, if you don't need, let's say as an example, you don't need fire sprinklers because you're in an ag exempt area. Okay, well, how's your insurance company going to feel about the fact that you don't have fire sprinklers to protect your building? So think about some things like that. The AHJ is allowed to interpret the codes. Like I said, you can go to the state to contest it, but that does get tricky and it gets lengthy. So just be prepared to, hopefully you have a designer that has a good relationship with those people, and then it's usually not much of an issue. I said this in the beginning, but most cannabis codes will apply to hemp facilities. Sure, there's not THC or not much THC in the hemp, but it's, in my experience, at least on the facility side, there's really no difference. And so before we go into questions, I want to show you guys a few pictures because I promised kind of, I don't remember how it was put, but real life examples, lessons learned, so to speak. So this is looking down, this is my guys in the field, they came up with these. There was a facility that we visited that was basically out of code compliance, and they needed some assistance. So this is looking into a hopper for a hammer mill. The only thing I want to point out is that there's a fair amount of debris here, and when we're talking about dust explosivity risk, that can be an issue. So cleanliness of your equipment is an issue. This, I believe, is the power cord, more than likely not rated, classified for this type of use here. Okay, so what we're looking at here is, these are filter bags full of hemp in a freezer. You can see there's dust all over the freezer walls, and this freezer is not classified for this use. So this, you know, these components right here could easily set this thing a kaboom. Right here you can see there's a bunch of dust all over these electrical connections here. So this one is an ethanol recovery skid. And basically these motors here are Class 1, either Class 1 Division 1 or Class 1 Division 2 rated, which basically means they're spark proof, right? But it also means they're spark proof because there's a hazard exists, okay? So just because you have these Class 1, Div 2 rated motors doesn't mean you can do whatever you want around them. So in here, they've got a heating element inside their, I'll call it goo here, and then an ethanol tank right next door that's essentially open. They open it to fill it or to take things in and out of it. Now this is not uncommon. Like what we're seeing here happens all the time, because lots of times you have jurisdictions that don't know what's right, what's wrong. Well, the problem is that this heating element is really close to this ethanol tank. Now whoever designed the skid went through the effort of making these Class 1 Div 1, but the operators failed to understand what really needed to happen in this area. You can see right here, there's this fire sign, right? Like that there's an issue here. Well, you've got this heating element that could easily start a fire. So this is just a good example of why your operators, and you really have to have good SOPs in place, and your operators need to really truly understand what they're doing in your facility in order to keep everyone safe. This is another example. This is a freezer that has, so the room itself is rated. It's got a 2-hour wall on it, and then they put a freezer inside, or a refrigerator or something inside that was not classified, thinking that because this was rated, and this is the, this is the architect should have known this, but thinking that because this is rated, that now you can put anything you want inside of it. Well, that's not the case. What they did here is they just built a really cheap bomb, right? If something happens in here, now this whole thing's just gonna go kaboom. So inside this freezer, they're storing the